Hey guys, so here's number 5 from exam 1 from fall 2017. So this one is a loop analysis problem, and so the first thing we need to do is draw some loops. So the big thing that I do that I highly recommend you do is to make all your loops in each window pane of the problem, to make them all clockwise and keep them all the same. And that'll just really help simplify your life and help you not make mistakes. So what we'll do is we'll just go ahead and label these. We'll call that one I1. We'll call this one I2 and I3. So you need as many equations as you have unknowns. And sometimes you can simplify things a little bit, but I'm going to stick to keeping it a little more complicated, so we're going to end up with a 3x3 matrix. And I'm also going to do this one the fast way, because I think the fast way for mesh analysis is pretty easy, and anybody can learn it real quick, so we're just going to do it. Alright, so once again, I like to label everything. So we'll label our columns right here, I1, I2, I3. Now the big thing about doing mesh analysis is to remember that current supplies are like poison ivy. So watch out for these current supplies. Like this guy, you can't walk through them. So I like to call this the walkabout method, because we're going to walk around the circuit. But the thing to remember is that you have to have as many equations as you have unknowns. You cannot walk around through a current source whatsoever. Always walk in the clockwise direction, and while you're doing that, we'll have to walk in some way where we account for every component in the circuit, but we don't cross through one of these current supplies. So when you do have a current supply, though, it's kind of a gimme. So like right here, you can see that real easy, like this I3 current right here is just going to be equal to minus 2 milliamps. So we already know what I3 is. So we can say, we can define it either way. And we could say probably, we can make I1 a 0, I2 a 0, because that 2 milliamp source doesn't touch anything but I3. And then we can say that I3 is equal to minus 2. And so that's because they're going in the opposite directions. So that's a gimme, that's an easy thing, but it also means that we can't walk through that window pane. But we have other window panes to walk through. So the big thing that we're going to do is we're going to start, let's start with this guy right here. So we'll put a ground right here, and we're going to do, I call it the walkabout method, and we're going to walk through here. So we're just going to count up however many resistors we found. So we found one resistor, we're going to walk, we're walking clockwise, we're walking down, down, all the way back to where we started. Alright, so how many resistors did we count? We counted this guy, we counted this guy, so there's 2 resistors right there. So we know for I2, we're going to have 2. Now, whatever touches that window pane that we walked around, or that path that we walked around, we're going to write the negative number for that. So this resistor doesn't touch anything else, but this resistor right here touches I3. So for I3, we're going to write a negative 1, because there's only one resistor with 1K, so we just write a negative 1. And it doesn't touch anything over here on this I1, so we're just going to write a 0. Now, however, we did walk through this 6-volt battery supply, and you know, if you were to write out the equation, you would go positive to negative, so this would be a plus 6, but when you, because it's a constant, when you switch to the other side, we're just going to write minus 6. So we have 2 equations, and we need 3 equations because we have 3 unknowns. So we can walk through the top I1 pane because that has no current sources in it. So we'll start right here, and we'll just walk, and we'll count up however many resistors we walk through. So there's 1. We keep on walking, 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 walking. Walk all the way down, and that's poison ivy. We can't go down there, right? So we keep on walking here. So we have another 1K right there, and we have a minus 6-volt supply there, which we'll talk about in a minute. And there we go. So once again, I1 is just equal to 2. And then the next thing that we're going to do is we are going to see what is it touching in terms of window panes, and we're going to say that's a negative. So once again, it's touching this guy right here is touching I3, so I3 is just going to be -1. So literally all we did is count. We didn't even write a single equation to account for anything. And so the other thing is we were walking clockwise, so we walked through this. So this is a -6 if we were to write out an equation, but when we go to the other side, we flip the sign and it becomes a +6. We got +6 right over there. So once you do all that, you should pop out the answers, and you should get something like, let's see, I think it was a 2 and a -4 and a -2. So that's your currents that you found. And now it's asking you how much power was absorbed or supplied by the 6-volt source. So we know the current going in and out of the 6-volt source is just going to be I1, because I1's going in this direction, and it's going to be also minus the I2 going in this direction. So I1 minus I2 is going to be equal to the voltage supplied, the current supplied or coming out of the 6-volt source. And so if we look at that, it's going to end up being I1, which is 2, minus, and then I2 is equal to -4. So we know that's what is coming out of there. And so as you can see, that's going to equal 6 milliamps. So we know that this is supplying 6 milliamps. And then we know that power is equal to current times voltage. And so we can say that the 6-volt source is supplying 6 milliamps, and it's supplying 6 volts, and that's going to be equal to 36 milliwatts, and that is supplied.